All right, let's get started for our notes. I'm going to start with a little review and then kind of tie everything we've been doing together. And then tomorrow we'll have some things that are a little bit new. And then, again, your quiz will be on Friday. Got that? So, just to begin, recall that everything we're doing revolves around the idea that the circumference of a circle is 2 pi. Okay? Dang it. There we go. Which, as we remember, is the same as a full circle or 360 degrees. Right? So we're going to do a little bit of practice going back and forth between the radians and the degrees and just, keeping that straight in our minds. So if we know a full circle is 2 pi, so half a circle is pi radians and 180 degrees. Right? So if we needed to, we can convert from one to the other. Okay. So 4 pi over 3 radians is going to be the same as how many degrees? Okay. So 4 pi over 3. If I wanted to say, well, how many degrees that is, I can multiply by that the equivalence here. That the fact that they're in pi radians, there's 180 degrees. I'll multiply by that ratio, which is going to be 180 over pi. And the fact that I have a pi on the top of the radians here and then on the bottom of my ratio, they cancel out and you're left with just a number, right? And that's how we get our conversion going. So I'll have 4 times 180 and divided by 3. 3 goes into 180 60 times, or 3 goes into 18 6 times, and then 4 times 60 is 240 degrees. Now there's a little slight difference between the degrees and radians and what they measure. So if I took a generic angle, let's see here, let me go, give me a line, yeah. If I took a generic angle right here, from the origin to anywhere, right, degrees measures, we call that theta, by the way. The degrees measures this little space right here, and it doesn't matter how big or how small the units are here. So usually we're doing with 1 for our radii for everything in the unit circle. And the degrees, it doesn't matter what that radius is 1, 2, 3, or 4. That angle doesn't change when you're using degrees. But do recall that radians is more of a circumference, or a fraction of the 2 pi, right? What fraction of 2 pi is it? So it's like the perimeter, or starting from here, right, going to our reference point here. That's what radians are. It's like a fraction of the circle of the arc. Okay, so they do measure the same thing, like how wide, these two things are. They measure it in different ways. The difference with radians is that the unit circle, if this wasn't a unit circle, let's say it was a radius of 2, that the radians would be bigger, but theta would be the exact same. So just throwing that out there that there is a slight difference between the degrees and the radians. But with radians, we always stick with the unit circle, so, they tend to measure the same thing. All right, so we have lots of information we've done so far, so we're just going to combine it all together and, try to synthesize some of this today and digest everything, and then getting ready for our quiz coming up shortly. So first thing we're going to do, we're going to just go back to, sketching these out. What do they look like? What do they mean? All right, so draw a circle here, and if you want, you can draw it for each one of them. So 5 pi over 6, right? Now at this point we're looking at the denominator probably first would be a good thing. So if you see over 6, what reference angle or angle do you think of right away when it's over 6? If you look at that unit circle, what are you counting by if you're doing pi over 6? 30-degree angles, right? So you're looking at this as pi over 6, which is 30 degrees, and there's 5 of them. So you're really counting 5 30-degree angles. That's the way to look at these. So you can say 30 degrees 1, 60 degrees 2, 90 degrees 3, what was that next? 120 degrees 4, and then 150 degrees 5. So there's 5 30-degree angles starting at 0 to get over here. Okay. So whenever you see divided by 6, you're thinking of 30-degree increments. And there's 5 of them. That number in front is how many of those. Right? Now, another way of looking at it is saying that the what we call the reference angle, if I look at this, which is right there, I can say, well, let's look at the angle just from here to here. That's a 30-degree angle, or pi over 6. So in the directions, it talks about labeling the reference angle here. Right? That's what they're talking about. It's like a 30-degree angle. Here's the triangle we'd be working with. We know the radius is 1. We can find the y. We can find the x. Some people look at this 5 pi over 6 and they think, well, that's 6 pi over 6, right? Would just be pi. That's 180 degrees. So if you just take off a 30-degree increment, that brings you starting here and it brings you back 30 degrees to our 150-degree angle right there. There's a couple ways of looking at it. Counting 5 times from 0, or just count 1 time the other way. Right? If you're okay with fractions, you can see that 5 over 6 is really close to 6 over 6, which is 1 pi. Right? So either way, whatever way makes sense to you, use that method, right, and stick with it, because I've found over time people understand it in different ways. You don't have to pick the certain way that everybody else does. It's just pick the way that works. And it can change over time as well. Right? So we have the understanding that this reference angle is 30 degrees. And we could always go through, we can convert this using what we did up there and convert it to 30 degrees. Right? And we also know it says, what's the quadrant? So we land in quadrant 2. And if you want to, you can show the actual conversion like we did above. You might be able to do this without writing this out, though. Now, if you look at this and say, well, 5 over 6 pi, close to 6 over 6, but pi over 6 away from that, and you can come up with 150 that way as well. And that's the actual conversion. And we can do negative as well. When you see pi over 4, what increment do you think of when it's over 4? What is it? Look at your unit circle if you need to. All the over 4s, what are they? Why is this not working? Come on, give me a circle. There we go. Cool. Well, bust it up. Look at your unit circle. You tell me. Anytime it's over 4, what's the reference angle? With confidence, what is it? 45. Now we're awake. Okay, so we know that this is pi over 4 is a 45-degree angle. So I'm looking at 3 of them going in the opposite direction, right? So 45-1, 45-2, 45-3. So I'm looking at, there's my triangle, right? And it has a 45 degrees, reference angle. Just 3 of them in the opposite direction. That's all we're keeping in mind there. Of course, we end up in quadrant 3. And if I needed to, I could show my arithmetic on the conversion. Someone asked if they could do 360 over 2 pi, because there's 360 degrees and 2 pi radians. Yeah, technically that works as well. The standard is this, but however you want to go about it, that's totally fine. So that should come out to negative 135, I believe, degrees. So over 6 is 30-degree increments, over 4 is 45-degree increments, and over 3 would be the 60-degree increments, if you're counting. Okay. So that's just a little review of a little bit of things we did last week, right? So if you know the 30, 45, and 60-degree rules, they really work the same for every quadrant, right? The negatives and positives change, but really it's just the same thing, same answers all the way around. So that's all we're going to look at today. It's going to be pretty quick, just a reminder of how all this stuff works. So a reminder of sine. So we have cosine and sine. So we looked at this last week. Cosine r, comma sine of r. So we started using cosine, comma sine instead of x, comma y. So anytime you see cosine, you're thinking of the run. Anytime you see sine, you're thinking of the rise. And we actually also looked at tangent, which was basically rise over run. So finding the slope, which is rise over run, which was sine over cosine, which is the same as slope. So every time you get asked the question, what's the tangent of, they're asking for the slope of, right? And you can get that just by looking at the graph and seeing, okay, that's up 1 over 1, slope is 1. It's vertical, undefined. It's horizontal, slope is 0, tangent is 0. So always reference back what you've already learned about slope and rise and run when you're doing sine, cosine, and tangent. So you realize it's not just a bunch of steps that you're learning brand new, but it all relates back to what you've done before. There we go. Actually, so pi over 4, what's the angle? Where does it belong? Yeah, right here. That's right there in the middle. Okay? So that makes a triangle. What kind of triangle? Yeah, it makes that 45, 45, 90. So that's what we looked at on Friday as your homework. You had some 30, 60, 90s and 45, 45, 90s. And a bunch of rules, right? For finding the missing sides. So let's put that to a test right now. Say, on your homework, the hypotenuse was a bunch of different numbers. On your unit circle, the hypotenuse is always equal to 1. So what does that make the x and y equal to? So what is x and what is y for each one of these? So how do you go from hypotenuse to leg with a 45, 45, 90? Yep. What's that? Very close. Very close. Is it 1 times root 2? 1 over root 2. Because we're going from hypotenuse to leg. If we're going from leg to hypotenuse, it is multiplication. And what do we know? What's the relationship between x and y? They're the same because this is a 45, 45, 90, and in geometry you learned if you have an isosceles triangle, 2 angles are congruent. That meant the 2 sides are congruent as well. So anytime you got 2 angles congruent, the 2 sides are congruent. Right? So we get both of those, but we can't leave this in this form. We got to rationalize the denominator, so we multiply both of them by root 2 over 2. and they came out to root 2 over 2. So that means the x-coordinate is root 2 over 2, and the y-coordinate is root 2 over 2. So it kind of, another way of saying this is that the x-coordinate, the run, is root 2 over 2. That's at length right here. And the rise is also root 2 over 2. And we leave it at this fraction. We don't get the actual decimal. You could punch in the calculator, get 1.41 and then divide it by 2, get 0.707. So technically it's 0.7 over 7. The whole thing is equal to 1, so it's about 70%. Right? So this question right here, when it says what's the sign, remember it's asking you what's the y-coordinate, what's the rise. You always want to be thinking about, what does this actually mean? They're asking what's the y-coordinate of a 45-degree angle. What's the rise if I have this angle is 45 degrees, right? How much does it actually go up, right? What's that actual rise? So we want to know what the answer is, but we want to know what it actually means as well. So turns out the sine and cosine are identical with any 45-degree increment, right? So usually when you see over 4, the sine and cosine are the same number, right? Because if it was over here, it'd still be root 2 over 2, root 2 over 2. It's just the cosine would be negative. And down here, it would still be root 2 over 2, root 2 over 2. They'd both be negative, right? So if you know the reference angle, the 45 degree, you know all the other possibilities as well, as long as you can do which one's positive, which one's negative for each quadrant. And we did that, what is it called? All-Star Trig class or whatever it was. So all students take calculus, right? There's different acronyms. If you learn that, which one's positive, if you just learn the one that's positive, you know the other ones are negative, right? So that's a fast way of looking at this. Saying that, okay, this equals, the answer is root 2 over 2. You'd always leave it as the exact format, never put a decimal, by the way. And ask yourself, what other angle has the same answer? Okay, and that's the last part I'm going to add on today. So what other angle also has a sine of pi over 4? Or what other angle also has a rise of this root 2 over 2? Right, so you want to look at it like, well, the rise, that's the y-coordinate. So if I drew a line across, that if I had this angle, which is 3 pi over 4, that's at the same height, right? This and this have the same height. So it's worth at this point to start thinking about that the answer for this is the same as the answer for this, because they have the same rise. So we like to know what the rise or run or the sine and cosine tangent is, everything. We also want to know, like, oh, but in this quadrant, it's also the same answer because they're both positive, right? So this is the next big skill you want to be thinking about. For reasons later on, when we really start doing a lot of this math and we have answers in different quadrants or both quadrants, you can quickly say, well, if I got an answer here, that's the same as the answer here. In future calculus problems, sometimes you can't find something called the derivative of a certain angle, but you can find the derivative of its equivalent somewhere else in a different quadrant. So it's a backdoor way of solving math problems. If you say, well, I know these have the same answer. I don't know how to solve it directly with this one, but if I solve this one, I can get the answer. So that's the value of it. It kind of gives you a different tool for getting answers to future problems. All right. So lastly, just one last problem. So we see a pi over 3. So anytime you see pi over 3, you're thinking a 60-degree increment. So pi over 3 is 60, and we have 2 of them. So that is going to be like a 120-degree angle, which lies in quadrants. Snap it wrong. There we go. This, and So 2 pi over 3 would be right about here. Okay. It has a reference angle of 60, which means it has all the properties of a 60-degree angle. Just some things are positive, negative, right? So here we go. That is a 60-degree angle right there. If I blow this up over here, if the hypotenuse is equal to 1, what's the x going to equal? What's that going to equal? What's that run going to equal? So how do you go from hypotenuse down to the short leg based on your homework you just did? Give you a chance to think about that. And of course the answer is divide by 2, take half. Right, so if I remember, it's if you double the short leg, you get the hypotenuse. So if you're going by hypotenuse to short leg, you take half. You do the opposite, or inverse operation. So I know that the run, or the length, is 1/2. What is the rise? So it's that 1/2, right, times root 3, which is how we get root 3 over 2. We combine it. So if I wanted to find the rise, or the sine, that would be root 3 over 2. Okay. So for here, we get cosine 2 pi over 3 equals 1/2. All right. Right. Nobody yet? Okay, why is this the wrong answer? I was waiting to see if anybody would catch it. So why is this wrong? Cosine is negative in the second quadrant. Remember, we went this way to the left. So this is technically a negative 1/2. So we can do a lot of this math. Remember, the positive negatives are going to be your main focus on your quiz. I'm just telling you that right now. It's nice to come up with this and do this triangle and say, oh, it's half. Okay, that's root 3 over 2. But then you forget what quadrant your answer is in. We're in quadrant 2, right? So cosine is negative, sine is positive, right? So that's why we have that. All students take calculus or whatever acronym we want to use, and it helps you remember the sign of your answer before you even actually start the problem. All right, and this is going to be the same as what other angle? So over here, I saw that the rise of pi over 4 and 3 pi over 4, right, are the same. What other angle has the same run, the same cosine? And where is it? All right, so we got, now cosine is the run, right? So this negative 1/2. So it has to be negative, so it can't be here. All right, so right away I know, well, here's my first angle, so my other one must be right here. Right? So this is 3 pi over 3, this is 4 pi over 3. So cosine of 4 pi over 3 has the same exact run as 2 pi over 3. And they equal the same thing. They have the same run. Negative 1/2, going to the left. So if you think cosine, when is cosine's negative? It's when's x negative. Where is x negative? Second and fourth quadrant. If you think of sine being negative, where is y negative? Third and fourth quadrant, right? So always relate, if you're as you're learning this, getting used to the sine cosine business, just think of x and y as cosine sine. All the rules for the x-axis are the same as the rules for cosine as far as positive and negatives. All the rules for the y-axis are the same as the rules for, the rise, the sine, right? And that really, relating it back to all the math you've been doing for years is a lot easier than trying to remember this or recall this information as if it was brand new. So, but you might come up with your own method or whatever works for you. Just as you do more problems, it becomes clearer just by practice, okay?